Okay.
Is this your book?
Yes, let me explain. So, I'm going to change the stuff around a little bit. I wanted to be able to run out of time to finish that AP test. So I actually want to finish or put AP part 4 on Friday, but the free response has slow fields in it. So I felt like, to be fair, to do a question on slow fields, you should actually have seen slow fields.
I agree with that.
Oh no. Okay, so today I'm going to teach slope fields, which is in the book not until 104. And it's extra practice. The homework is extra practice or on 104 or front sheet, I guess, whatever you want to call it. Tomorrow you'll practice it a little more, and by Friday you'll think, oh man, those are layup points. Those are the easy points on that free response, and it'll go great. I will be gone tomorrow, so towards that end, two things. First of all, first of all, before I forget, I am throwing around a seating chart.
Thomas, we already got it going.
Oh, super. Oh, good job. Okay, so there's a seating chart going around. Keep in mind that it's from my perspective, the sub's perspective, so you're going to actually be writing your name with you and fields upside down. I put a few in there just as a reference so you know where stuff is. Done. Now, tomorrow what you'll be doing is, the good news is, you will not have homework tomorrow. And there's not any bad news, so it's always nice when you just hear good news. Tomorrow in class, you will find this book under your desk, okay? It's the mini book, the Mana book. This is probably, along with the Larson book, the most common, most popular calculus book at most high schools in America, anyway. It's okay. It's not very challenging, I don't think, for your level. If I were teaching at a regular high school, I'd probably find it just fine, but it's beneath you, quite frankly. You're better than me. Okay? Now, that said, I know you've been thoroughly Saxonized, thank goodness, but most math people and most schools throughout the country, Saxon is like a pariah. Nobody uses Saxon. But most books or most schools, when they learn slope fields, tonight you do 30 slope field problems. And then tomorrow you don't do any slope field problems. And then you do something else, 30 problems of that. And then the next day you do 30 problems of some new thing. And then when the test comes, you cram like crazy because you haven't done slope fields in 4 weeks. And when the final comes, you're really screwed because you haven't done slope fields in 12 weeks. But that's it. That's why I feel like the learning sticks better with the way we do things. I love how we do things. But that said, the point I'm trying to make is there's a huge chapter of just slope field practice. That's what you're going to be doing in class tomorrow. You're going to use this book and in class do the problems I ask you to do. I still have to make that up. And you'll turn it in at the end of class. The length of that assignment will be based on what I would consider the average student. If you're a slower worker, at this point I know who works slower and faster, and if you have a little less done than the person next to you, and I know you're slow, no harm done. As long as the sub says, yeah, they were working all period, then you're good. If for whatever reason I get a letter back saying, hey, this kid was a clown, or this class was a clown, then you can expect the test from hell on Friday. Okay? I will find the hardest problems I could possibly find, and that will be your test. All right? So I would suggest you work hard tomorrow for the 50 minutes and enjoy no homework. Understood? What? My daughter's on spring break from college, so I'm going to spend the day with her. Yeah, so it'll be good. I'm excited. But I have it's impossible to get stuff. I called 7 subs. Every one of them is busy, so I don't know. I just hope they're breathing. I don't know who I'm getting. I mean, I didn't even try to get somebody who knows math. They just are an adult. That's it. And so that's it. I would. if it wasn't the law, I'd say, you know what, they're fine, just let them do their thing. I've read them thoroughly, they know the deal. But, the law's the law. Okay, so do you understand the process for the next 3 days? Are we all good? Okay. This lesson, anytime a student picks up these notes, I always hear the same thing from kids coming, oh, this looks hard. It does look intimidating, I thought the same thing when I looked at it, it's really not that hard, you'll find. It'll go very well. All right, you ready? Okay, so by the time I'm done with you, we will definitely have the 4 big ideas. I don't think I'll get to the 2 little ideas, but the 4 big ideas you'll be able to do are draw a slope field. Actually, I guess step 0 would be, you'll know what a slope field is, but then you'll draw a slope field. You will also draw a particular solution curve over a slope field. Again, these mean nothing to you yet, which is usually why I don't start with objectives, but these are the objectives along the course of the problem. You'll also be able to match a differential equation, or diffEq, to a slope field. Some people just abbreviate it DE. And you'll also be able to match a solution equation to a slope field. I might come back and get those little objectives at 1 and 2 later, so let's leave those. I will not have time. They are on the notes, but maybe I'll get to them Friday or next week. All right, so that's where we're headed. First, let's start, shall we? So, usually when you see a slope field space, there's lots of little dots. Maybe on the back there's such a, nope. On the homework, look on the homework, you see on the back there's these little dot fields. That's usually what a slope field space looks like. They put little dots to indicate this is where I want you to draw slopes. I'll explain, but for now, this is the deal. I'm giving you a differential equation which tells you what the slopes are at any given point. And based on that, I can plug in any point and figure out what the slope must be. So for example, if I said, what's the slope at 0, 0? Well, the x of 0 wouldn't matter because there is no x in that differential equation. But the y of 0 would tell me the slope is 2. Now, this is what I want you to do. Go to 0, 0, and imagine a point that is up 2 over 1 away. So, for example, the point 2, 1, 2. You see that point? If the slope is 2, then I would take a slope of pointing in that direction. The slope would be about that steep. Now, you only make it a little baby slope because the minute I go off that point, y is different. And if y is different now, then the slope is different now. So I can't say it's 2 forever. It's just 2 for a second. Yeah? Now, if I went 1 up to the point at 0, 1 on the y-axis, well, the slope would be different. What's the slope at this point? 1. Now, if I put my pencil there, then I would point at a point that's 1 up 1 over 1 away. So the slope should be less steep than the one beneath it, because obviously the slope of 1 is less than the slope of 2. If I went 1 above that to 0, 2, what's the slope? 0. And 1 more above that at 0, 3, the slope is? So imagine going down 1 over 1, but make a small slope. Let's go to the bottom. At this point on the y-axis, at y equal negative 1, what's the slope? 3. Now, you could either imagine a point that's up 3 over 1, or you could say, well, I know it's steeper than this guy, so you should get a little steeper, and I think you'll agree that as you go down, the slope should get steeper and steeper. So, doing this quickly, you should start looking like that, all right? Steeper and steeper as you go down. Now, it's frustrating teaching somebody this, you'll find if you help somebody. because it takes a while to gradually get this fast. But that's okay because you're human. And as humans, it's natural that you will say, this sucks, this is way too much work, there's got to be a better way. That's human. Well, there is a better way. You need to look for it. You look for trends. Do you agree that these slopes get steeper as you go down and negative as you go up? Yeah? Likewise, when I go here, I doubt I'm going to reinvent the wheel and say, all right, now let me do my slopes again. Y is 0 here, so the slope is 2. Here, in this column, are the y's any different than the ones next to it? No. So these slopes should be exactly like those slopes because x doesn't matter. When I put in 1, 0, the slope is still 2 minus 0, so 2, just like the one left of it. So these slopes should be just like the ones in the first column, getting flatter as you go up and then negative and steeper as you go down. And you can continue to do that, matching the slopes. And in the interest of time, would you just go from a x of negative 2 to an x of positive 2, so we have 5 columns of slopes? As you look left to right, the slope should be exactly the same. But as you go up and down visually, the slopes should be different. All right, so we could continue on forever. Usually on an AP test, this is pretty typical part A of a free response, and they'll have you do maybe 12 points. They won't have you do as many as we do. All right, you follow me so far? Okay, cool. Let's go to B. B, you can see the derivative or the differential equation depends on x. So when will the slopes change and when will they be the same? As you go side to side, the slopes will change. But as you go up and down, the slopes will stay the same because the slopes depend on x, not y. So what about at 0? What's the slope? 0. And won't the slopes up and down from that all be 0 because x is 0 everywhere? Okay. What about at x equals 1? Slope is 2. Up and down, slopes stay 2. So all those should be 2. Imagine a point up 2 over 2 away. You want to do your first slope really well, and then just copy it up and down. What about at x equals 2? Slope is 4. Steeper, and then parallels to it up and down. And then at x equals 3, the slopes are 6, so even steeper than the ones left. So the slope should look steeper and steeper as we go out to the right. On the left, what's the slope when x is negative 1? Negative 2. So imagine a point down 2 over 1, and then copy that slope. You could also say the reflections of the ones on the left. And then steeper as you go further and further away from the y-axis because x is getting bigger and bigger. The slopes get bigger and bigger. So your slope field might look something like that. Are we good? Okay, cool. Now the last one is going to take a little longer because it's not as easy to see the trends. It's not always this or always that. But you can still start with 0 slopes. Where is this 0? This would be 0 slopes anywhere x and y are equal or opposite sign. Good luck. Opposite sign. So if you actually set x plus y equal to 0 and solve it, won't this be 0 when y is negative x or the opposite of x? Mm-hmm. Well, y is the opposite of x along this pattern. And it's easiest to start by finding 0 slopes. They're really easy to draw. You see where I'm coming from? All right. Now, rather than go horizontally, we're going to continue to do this diagonal pattern. Would you go to 1, 0 and tell me what the slope is at 1, 0? 1. So the slope is 1 there. So imagine a point up 1 over 1 away. Now, keep going along the diagonal trend. So let's say we look at this point, 2, 1. What's the slope? 2, you're right, it would be 3. I misspoke. 2, -1, the slope is 1. That means then that everywhere just above that diagonal, the slopes are 1. Then do another diagonal over, say the point 2, 0. What's the slope? 2, 0, the slope is 2. And again, anywhere else along that diagonal, the slopes will also be 2. So 3, -1, the slope is 2. 1, 1, the slope is 2. So those slopes are 2. At 3, 0, the slopes are 3, so a little steeper. At 4, 0, the slopes are 4, so a little steeper, yeah? All right, what about at -1, 0? Slopes are -1. At 0, -1, the slopes are -1. So if you continue, that's actually a really interesting solution in differential equations. It's a place where you have a trivial solution or a linear solution. All right. I'll come back to that. All right. What about at -2, 0? What's the slope? -2. So a little steeper and diagonally all the same. A little steeper. At -3, 0. -3, a little steeper. -4 along the next diagonal. So something like that. Yay? Okay. Now, let's pause for a second here. Maybe I'll come back. I think I'm going to do this first and then come back to that. Okay. So, next idea is a particular solution. Now, there are many solutions to any differential equation. Remember, when you solve a differential equation, you integrate to get the original y-x equation with no derivative, right? All right, now there's lots of solutions, considering they all have this plus c, and depending on what the c is, they could all look different. Same shape, but different places along the graph space. For example, if I drew possible solution curves here, now this is fun, because it's like connect the dots for smart people. Did you ever do dot to dots when you were a kid?
Yeah.
Okay, so this is cool. So imagine this guy, you know the graph went through this point -1, 0. Then wouldn't this mean go up? But the minute you go off that point, the slopes aren't going to stay that way. And now they start to get flatter. And so then the slope starts to go that way. Likewise, this way, the slopes are this. But the minute you go off this, they start to get steeper. So you might say a curve looks like that. Or another point through here might look like that. Or here. And it's possible that you have graphs up there above that flat line. What would they look like?
They'd be coming down.
Like this, yeah. Okay, so there are lots of possible solution curves through that. Now when you do those red lines, or one red line, that's estimating or trying to sketch in a particular solution. On the middle example above, would you find the point 2, 1 in the first quadrant, yeah? Now we're going to try and figure out, all right, if I knew that it had that derivative, but also contained the 2.21, what would the graph look like? Well, what is the slope at 2, 1? 4, do you agree? Yeah. Okay, so it's 4, but again, the minute I go off that point, the slopes are going to change. As I go right of that point, are the slopes going to get steeper or flatter? Steeper, because x will get bigger, the slopes will get steeper. So it's actually going to look like that. As I go left, will x get bigger or smaller? Smaller. So will the slopes get steeper or flatter as I go left? Flatter. What happens when I get to the axis? What are all the slopes at the axis? Flat. What happens as I go left at the axis? All those slopes are negative, and so it'll be, now if you're thinking, oh man, I must have done this wrong because my low point wasn't at -1/2. It's an S, it's a kind of, is it the right shape? Don't worry about how low. They're just trying to basically follow the slopes in the direction they say to go. Very good. Thank you. All right. Now, you might say then, well, why do the slope field thing at all? Why do this red curve when I could actually just integrate that freaking thing and look at what the graph really looks like? You could do that. Could I do a little separation of variables and say something like dy is 2x dx, and therefore y is x squared plus c. And if I use the point that it went through, 2, 1, then that implies that 1 equals 2 squared plus c, so c is -3. So I could actually know that that derivative with that point should yield the curve y equals x squared minus 3, and obviously my graph didn't go down far. You with me? Well, the reason is because not everything is integrable. For example, this, it can't be integrated. And yet, despite the fact I can't actually integrate that to get the original y-x equation, I could still get the graph based on how the derivative or the slopes behave. So this idea of slope fields isn't used so much as for stuff I can integrate, although we will do stuff like that because it's good exercise. But it's mostly used for non-separable differential equations that I can integrate, and yet I can still know what the equation looks like. All right, now then, would you go to this bad boy, and would you please draw a few possible solution curves? Pick a point and try and figure out what the solution curve would look like through that. So any point, the origin, 1, 1, whatever. Just try and get a feel for what a curve would look like. And after you draw one, draw a couple more. You have a couple? So do you have something like, ooh, it's getting steeper and steeper over here, but all flatter and flatter, all in the negative? So something like that. Yes. And then maybe like that if you did one lower. And what about over here? What do these slopes curves look like? Down, yeah? Are you with me? Yeah. And then there's really one wacky one that doesn't even curve at all. It's right there, yeah? Yeah. All right, now let's go through this math. So let's extend this a little, all right? Let's start with this. It looks like this yellow line. Y equals, what does that look like as far as the solution curve? Y equals negative x minus 1 is a solution, it looks like. Yeah? Now that seems kind of whack to me, because if you took the derivative on that, what's dy dx? -1, right? Not x plus y.
Oh, yes, it is.
And yet, it is equal to x plus y. How?
Oh, -1 of the...
Yeah, what is -1 equal to if I isolate it? X plus y. If you take y equals negative x minus 1 and isolate -1, -1, if you substitute the equation itself back in, yeah, it's true that those two could be the same at the same time, yeah? Second idea here. Would you please find the second derivative for me? What's the second derivative of that equation? can shut it out. What's the derivative of x?
1.
1. Great job. What's the derivative of y?
1.
dy dx, yeah? What is dy dx?
X plus 1.
X plus 1. Cool? All right. I think you'll agree that the second derivative, which is 1 plus x plus y, is greater than 0 if y is greater than, isolate that y, please. 1 plus x plus y, the second derivative is greater than 0 if y is greater than negative x minus 1. Here's negative x minus 1. Y is greater than that or above it. Are those curves concave up? Yeah, unless.
Oh, very fancy.
All right, pretty cool. All right, let's go on to some matching. Now, these are very common multiple choice problems. On the AP test, there's usually one multiple choice and one free response that involves slope fields. The total layups, there'll be softies that you'll always get right if you do your job. Okay, so here's the deal. When I go to match, there are actually 4 different things going on in my head, and it's just a matter of which one you use first makes your life easier. And so the first thing you should probably consider is zero slopes. So when I go to choose which of these differential equations makes that slope field, the best place to start is where would the slopes be 0? Just set this equal to 0 and move stuff around a little. Do you agree that this would be 0 anywhere y is the opposite of x? If y is the opposite of x, those slopes come out 0, okay? Are you with me?
Yeah.
Okay. Are these slopes 0 along y equals the opposite of x? That's definitely not. Okay. What about this? What kind of situation would make these slopes 0? When x is 3. Well, I think you'll agree that at x equal 3, these slopes are definitely not 0. These what I would expect at 3, the slopes to all be flat everywhere there, yeah? That's not it. This is 0 when the top is 0 or the bottom is 0? Top is 0. We have horizontal tangents when the top is 0, vertical when the bottom is 0. So I want to know where is y equals 0. So here is y equals 0 along the x-axis or the y-axis? X-axis here. Are these slopes 0?
No.
Definitely not. That's not it. Okay. Where are the slopes 0 for the fourth differential equation? Where y equals x or x equals y. Is that a possibility? Are these 0 along y equals x?
Yeah.
Yeah, so that's still in. And what about the last one? Same deal, y equals x, all right? Now, it feels like I've narrowed it down to the last 2. Do we all agree so far? How can I choose between those 2? Yeah, a point helps choose between 2. You definitely don't want to use that as your primary method because it's super tedious. A point helps choose between these 2. So let's just use the point 1, 0. At 1, 0, obviously the slope field says the slope should be positive, right? This first equation, at 1, 0, is the slope positive or negative? Positive. What about the second one? At 1, 0, the slope is negative. So it's definitely not that one. It must be that one. If you use 1, 0, slope is positive. Choose D. You with me? Try the next one on your own then. kind of harder to see this because it's an axis. We'll make it. ¿Listos? Sí. Okay, where would the first differential equation be 0? Where x equals 0. Where x equals 0 is along the y-axis, are the slopes 0 there? No, that's there. What about the next one? The slopes are 0 where? Y equals 0. Now it's hard to see that, but it seems like at least the slopes aren't sticking up, so they're definitely a possibility, though. It's hard to see because they're on the axis, but maybe? You with me? All right, what about for the third one? The slopes are where x equals 0 or y equals 3? All right, 0 slopes are where the top is 0. Vertical slopes are where the bottom is 0, though sometimes they don't actually draw the vertical slopes. They just leave those blank. But we want to focus where x equals 0. And we already said in the first example that x equals 0 is not a place where slopes are 0, right? Because that's at the y-axis. What about the fourth one? Is it a possibility? Yeah, y equals 0 there, and that might be a case, yes. And what about the last one? Are the slopes ever 0 here? No. Furthermore, as x gets bigger and bigger, I should have negative slopes here. It just feels wrong because negative x's should have negative slopes, and that doesn't have negative slopes. So that's how I ruled that out. We'll talk about sign in a minute, but take my word for it, 5 is not it. All right, so how do I choose between B and D?
Well, you can pick a point.
You can pick a point. You can also think domain. What would the slopes be for negative y's? You can't. There should be no slopes for negative y's. Yeah? Because they're imaginary. Do you have slopes in negative y's? Yeah, so that's bad. Okay, so I know that that's not it. This wouldn't exist or make slopes in the lower region. You could also use a point or two and get there, but it is B. You with me? Okay. All righty. This is a bit of a. We'll talk. All right. So another thing besides 0 slopes is I consider signs of slopes. So I'm trying to match this slope field based on signs and zeros. Now, if I have the equation negative xy, in the first quadrant, would all slopes be positive or negative? Negative. In the second quadrant? Positive, because I have a negative of a negative x and a positive y. That would turn out positive, yeah? When x and y are both negative, I'd have 3 negatives, that's negative. And when x is positive, y is negative, I'd have 2 negatives, that's positive. So based on that, is A still in as a possibility? Yeah. It is. Where would this guy have positive? Where would it have 0 slopes, first of all? 3. And right of 3, positive or negative slopes? Negative. And left of 3, slopes are positive. So is second one in or out? Out. All right. What about the third one? So anytime you have products or quotients, this sign idea works very well. What are the signs? What would this slope sign come out in the first quadrant? Positive. Is that enough right away to say that's not it? Yeah. These are negative slopes, so that's out. What about this? Where would the slopes be 0? Where x equals y. So I should see 0 slopes that way, and positive over here, negative over here. Is that? No. Okay. And what about the last one? In the negative, so it'd be negative, positive, yeah?
Yeah, it's contender.
All right. So A and D, or A and E are in as possible contenders, yes? Let's choose.
Let's pick a point.
As x gets bigger here, say I just set y in stone, okay? Just leave y as one number. As x gets bigger, should the slopes get bigger or smaller?
Bigger. We get more negative.
Right, so for example, I should say steeper or flatter is what I should have said. You're right. Positive versus negative, that's bad. No. As x gets bigger, will the slopes get steeper or flatter? Steeper. Is that what's going on here? No, that's not it. Now, don't circle E yet. Okay? Here. As x gets bigger and bigger, shouldn't the slopes get steeper and steeper? And as y gets bigger and bigger, shouldn't the slopes get flatter and flatter? So this is
Also
not it. The actual equation I did not include. What do you reckon it is?
Y over X.
It's negative y over x. As y gets bigger, the slopes get bigger. As x gets bigger, the slopes get flatter. Yeah.
So it's on the test for these problems, will it tell us if we have to use it and it's positive slope or using the
No, it'll just say which matches and it's all on you. I just want you to have a couple different things going through your head. Okay? Each problem I use a little. I use zero slopes more than anything else. It's the best. But other ideas come into play too. All right, would you do the next one here and tell me? Yeah, just go. If you prefer zero slopes, cool. If you want to practice the signs, that's a good idea.
Oh yeah, that's gonna be. Oh yeah. That's gonna be. Wait, that's also. Wait a second. Positive, that's two. Okay.
Right? Okay. The first one, what do you say? Yes or no? Okay, it definitely has the right, right, left, positive slope, negative slope kind of thing going on. Feels like it would be 0 at y equals negative x over 2, yeah? We'll come back to that. I'll leave it in. What about the second one? Yes or no?
No way.
No. Based on signs, everything in this quadrant should be negative, or so you can definitely rule out B by signs in the quadrants. And what about C? Same deal, same quadrant signs. It has no right situation. Yes.
Could you do like the asymptote though?
You
So y equals 0.
like here.
No, like the one above that.
This.
Not like if y was 0.
This should be 0 at x equals 0 and y equals 0. Is that what you're saying, like that?
That be okay?
Yeah, you could do that. Okay. Yeah, you could use zero slopes for that. What about the fourth one? It should be 0 along x equals y, yeah?
Yeah, that's
Is
just
this-
not true. No, that's just not
That's
true.
not it. So I use zero slopes there. And the last one, there's no zero slopes, but I think you'll agree that for any positive x, the slope should be positive, and for negative x, the slope should be negative. And that's not what's going on here, yeah? Do you agree?
Yeah.
So it's this one, but it's not really this one. Why not?
Because I just don't want it.
Because the slopes are not 0 along negative x over, wouldn't that be here?
No.
Rise 1/2 right?
We don't have a scale.
And so, yeah, it's actually none of these, but, again, I'm just, so I didn't really mean to, I just typed them wrong. My bad. But now I'm pretending that I'm really trying to make you think. Alright? Way to go, me. Okay, so, next idea. Sometimes you are asked not to match a, oh, actually, never mind, sorry, one more sloping idea. Based on the slopes, and if they change horizontally or vertically, you should be able to say, oh, I'm looking for a differential equation that only has x in it, or only has y in it. So for example, if I gave you the differential equation, dy dx equals y over 2, it depends on y only. So slope should only change with y, or up and down. And side to side, they should not change. So let's consider, looking at these slopes, if I would expect to see a differential equation that had x in it, y in it, or both. This first one, does it change with x as you go side to side? Do the slopes change? So it seems like the derivative should depend on x. What about y? As you go up and down, do the slopes change?
It does not.
So this should be dependent on x. I would expect the dy dx to have x only. What about the next one? Do they change side to side?
No.
No, so x doesn't matter. Do they change up and down?
Yes.
Yes, so y does matter. So this depends on y. What about the third one?
That depends on why.
Y.
Oh.
And the last one?
It's on both.
Both x and y, because they change horizontally and vertically. And again, I said this on the first page, but when you have it narrowed down to two choices, you can always decide by using a point. Yeah? All right. Next idea. Instead of matching a differential equation to a slope field, sometimes you're asked to match an actual original equation to the slope field. The best way to do this is try to sketch each equation over the slope field. Let's do the first one together, for example. Now, if this is the slope field I'm working at, if x squared plus y squared equals 4 yields that slope field, then if I sketch that on top of it, the slope should kind of match my curve. What is x squared plus y squared equals 4? It's a circle. So if I graph this, does it look like the slopes actually match that circle?
Yeah.
It seems like
There we go.
that seems like it. But let's go through and decide. No, let's do the exercise. What's this graph look like?
That is a hyperbola.
A hyperbola. Do these slopes match?
Oh no.
No, I mean these should be positive, but that's definitely negative. That doesn't match. What about y equals e to the negative x? Exponential growth or decay?
That's so wrong.
Decay, and flipped over the x-axis or the y-axis? Y-axis. So this should be something like decay flipped down. I would expect it to look like that. Does it? Does it?
No,
No.
there's absolutely no way.
Okay, and 3 plus e to the negative x would be exponential decay shifted up, and again, that does not match the slope. So you can sketch on top, or at least imagine sketching on top, and see what works. Try the trig one on your own. Trig ones are a little harder,
Oh jeez.
but if you just know your four shapes, positive sign, negative sign, positive cosine, negative cosine, it should be fine.
Oh, I don't think that's it, guys.
Just pick a point and draw one through if you like.
Oh jeez. No, it's not fine. Right through.
It helps if you just draw a graph on top of the curve.
Looks like an illusion.
All right.
You guys get
What do you say?
2 minus cosine x.
2 minus cosine x. I got the shape there. Is that look like positive sine, positive cosine, negative cosine?
That looks like a negative cosine.
Negative cosine. It's got to be A.
So, Mr.
Yes.
Would the two doesn't,
The 2 just means it shifted up 2, so it's centered at 2, but it's still possible, yeah? Do you agree? Negative cosine looks like this. And 2 means it goes up 2. Does that match the curves?
yeah, but it has like
What do you mean?
like, if you draw it at different places on the graph, then it's
Yes, that's true. Yeah. But the only one that even has, so I don't even sweat the constant. I just looked at negative cosine, sine, cosine, and negative sine. And the only one that has the right shape is negative cosine. Okay? All right. That is good enough. I think I might come back to those little bits of the notes later. Let's, at the very least, see real quick how you did on last night's homework. It was a bit of a humdinger. There are a couple of them.
There's actually the word one. They were all like, no, like.
Some of the L'Hopital's were rough. All right. So, going across, did you get true, false, false?
Yes.
yeah.
Second row, false, true, false.
Yes.
False, true, false. And then the other 2, true, false.
Oh.
Okay. That's basically L'Hopital's rule, and you cannot take derivatives when it's a difference. It has to be a quotient. All right. Are we good there?
Yes.
Cool. This was 1. I had to do L'Hopital once there. It was pretty clean. This was 0. And I think I had to do L'Hopital twice there, or did I? No, once,
I
yeah?
did it twice. I did it
Twice?
Yeah,
Yeah, I did it twice.
that is twice, yes.
Okay. This one was b, negative 3 halves. 30, actually, let's pause for a second. So say you wanted to know if you were doing these right last night. Could you have figured out what the answers were on your own?
Yeah.
Yeah, how could you check your answers? Graph them. You have a graphing calculator. If you wanted to graph these and see as x goes to whatever, what does y approach? Your calculator will do it. Now these will never be calculator active, so you don't have to actually do the problem. But as a check on the homework, it's not a bad standby. 33 we did in class together, yes?
Yes.
30, oops, my bad.
32,
This guy was rough, negative 1/2. I had to do, first of all, you might have had a hard time getting a quotient, yeah? I had to decide which of these to make a quotient. I didn't want, this was ugly enough, so I called it 1 over x to the negative 1. And then I got a common denominator of x to the negative 1, so it became this. Then I did my L'Hopital. And I might have done it. I had to do it on other paper. I ran out of room. Okay. What are 2 equations implied by the rate grows at a rate proportional to the amount? The ADT equals AA and yeah, exponential growth. Those both have to do with exponential growth. Okay. 28 was not indeterminate. It is either DNE or negative infinity.
I got negative infinity.
Okay. 29 was not indeterminate. It was infinity plus infinity, which is infinity, or grows without bound. 30 was not indeterminate. It is negative infinity. None of those were indeterminate. 31, I had, what was this, a half?
I got 1.
It was
I screwed this up in the last class. It feels like I have, yeah.
Good morning, Douglas Scout Bus. Please rise for the pledge, please. Please begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Well, maybe not a half. Maybe one over east? Definitely not that. Looking at the graph. Nope, not one over east. Maybe one over east.
You know, Dublin has an environmental club. We're dedicated to making a positive impact in our community to help save our planet. We're collecting mascara wands for the Appalachian Wildlife Refuge.
My answer is wrong. It does not hold true. I thought it was infinity, but it's not. So I guess we'll have to go back to that. This one is 0 over 12. And this is -3.
Which one?
We did 34 in class, yeah. 35 is 27. A and B.
Everything will be donated if not placed up by Friday, March 20th.
36. I didn't have a calculator, but they said B, yes?
Yeah.
A, -1. B, 0. C, -1. And 37, I did not have a calculator. What did you get? Volume is roughly 9.144.
Are a starting point for a career in medical field. Both camps are run by local medical students
You didn't get
and
9.4.
medical field.
Oh, jeez.
Uh-oh.
Narrow it to line 13 through 17. Counseling as a detail. State Air Jumpers is hiring young adults age 16 and older to apply for some seasonal and part-time work. Check out the job opportunities board near the cafeteria. Ms. Weber's math SAT practice session for juniors only is today during 7th hour in her classroom. Please sign up with your math teacher. First
Okay,
come, first
so I'm feeling volume is shell with a negative X.
Junior high play will be Monday, March 16th.
Oh,
And
that's
G minus F.
yeah.
Dazzling Jack.
What I don't know is the intersection
Bands for
point.
qualifying for the State Concert Band Festival. 124 bands performed.
Yeah, because the figures over here, these are negative X's over here. So to get a positive radius, you'd have to do the opposite.
National Johnny Appleseed Day.
For that answer.
27.17.
Oh, that's what sounds familiar from what they had in the last class. 27-ish? I don't know. What'd you get for your intersections?
-4.009 and -1.90.
Okay. Thanks, Baptiste. All right. Anything you're we need to talk about this, or can we just
Hey,
turn
what
this
about
in?
31?
We talk about
Some of us have empty spaces on our paper.
What
You
about
talk-
31?
No,
we
actually-
Well,
I
hey,
love
I
that.
can't.
Well, I'll take
I'll
it Monday, or Friday, I'll take it Friday. If you have a lot of questions, would you look on my website? I'll try and put some hints and stuff on my.
Yeah.
31.
Tomorrow, Thursday, in the cafeteria during 7th hour. Please let us know the way to make the conflict.
Feels like should be a 0. Oh, no.
Andrew Day at Cassidy Sack.
Andrew.
You definitely not. Your behavior's only fine. Have a good day. Yeah, thank you. Have a good day. Have a good day. Thank you. Kendall, you sound almost like a healthy person, but not. Better?
But just not right.
Yeah, a little bit.
Alrighty then. So. I need to figure out what I'm doing. Stop recording.